So students, we have learned up to the matrices. In the last chapter we have learned the matrices and its operations on matrices, means algebra of matrices, different types of matrices, identity, inverse, all these things, how to multiply, how to add, all are come under operations of matrices. So now we will move to the next chapter, that is determinants. And in simple language we can say that it comes from matrices, means from matrices we can elaborate the determinants. Okay, so using matrices we can also solve the system of linear equations. Okay, means if you have two equations, we have learned how to solve by substitution method and all, but using matrices we can also solve the system of linear equations. Okay, suppose you have the equation a1x plus b1y equals to c1, a2x plus b2y equals to c2. So in matrix form it can be written as a1 a2 b1 b2, and this is xy, and here the constant terms c1 and c2. Okay, now so here you have to multiply these two, then equate with this one, this is equal sign. Now if you have to determine that whether this equation have a unique solution or not, then you just calculate a1 b2 minus b1 a2. So if this is not equal to 0, then the equation has unique solution. Okay, so this determines the uniqueness of the solution with the help of this matrix. Okay, and if we have to write the determinant, we write it as determinant of A, means if you take this as matrix A, then determinant of A equals to a1 a2 a1 b1 a2. Okay, determinant has many applications in your daily life, engineering, science, social science, etc. So and the very first thing we have to know about determinant is that only those matrices can be written, or only for those matrices you can return the determinants, or you can find out the determinant. Those are square matrices. Okay, non-square matrices have no determinant. For square matrix, and you know what is a square matrix? Square matrix have equal columns and equal rows. So one thing is very important: square matrix have determinants. Okay, so if, and what is square matrix, you all know, it's equal row and equal column. So if suppose you have a matrix A, B, C, D are the entries of this matrix. This is 2 by 2 matrix, means the order is 2 by 2. Then a determinant written as DETA or this type. In general we write this sign is for modulus, but here it is determinant, and this is written as A, B, C, D. Okay. So this is the determinant. And how we can find out the determinant? Determinant of a matrix of order 1 means which have only one element. If a matrix A has only one element, suppose A, then its determinant will be A itself. Okay. And for second order matrix, suppose this one, A, B, C, D, then determinant of A equals to this A into D minus B into C. This is the process how we find the determinant of a second order matrix. Okay. So one thing I will tell you, in videos I will explain the maximum, I will explain the concepts, and the sums, solved sums I will given you in the PDF form. Okay. The one which is required I can explain in video, but most of the sums I will give in PDF form. Okay. Next we have, this is first order, this is second order. Next, how we solve the, means how will we find out the determinant of a matrix of order 3 or order 3 by 3? Determinant of matrix of order 3 by 3. Okay. 3 by 3 means 3 rows and 3 columns. Determinant of matrix of order 3 can be find out by expressing it in terms of a second order matrix. Means you have to first transpose the third order matrix into second order, then we solve the matrix. But it follows some steps how we can find out, how we can transpose the third order matrix to second order matrix. So before going to that process, you have to know two definitions. First one is minor of the element Aij in matrix. Minor of the element means of element Aij means the element which is in the ith row and jth column. Okay. So what we do to find out if the minor, we just write, suppose you have a third order matrix A1, A2, A3, B1, B2, B3, A11, A12, A13, B21, B22, C31, C32, C33. Okay. So we just delete this row, this column and this row. Suppose you are finding out for A11, minor of the element A11, then you just delete this row, first row and first column. Then the remaining 4 element, using the remaining 4 element, you have to find out the normal determinant of second order. Okay. So it will be B22 C33 minus C32 B23. This is the minor of the element. Next, cofactor of Aij. How we find out the cofactor? This is, and minor of the element of Aij is denoted by, this is equal to capital Mij, I plus j into Mij. So cofactor of that element is find out by minus of 1 to the power I plus j and Mij. Okay. So these two definitions are important to find out the determinant of a matrix of order 3. We can find out, or we can transpose this matrix into second order by 6 ways. There are 6 ways. Means you can expand along the 3 rows or along the 3 columns. So first I will explain you. I will just explain one in one way. The rest are same. So right, expansion along first row means this one. So along first row, how we expand to find the, this is, if your this is matrix A, so determinant of A, first element is A11, so you write A11 minus of 1, this is your cofactor, and then M11, okay, then plus A12 minus 1 to the power 1 plus 2, here you can write 1 plus 1, and M12 plus A13 minus 1 to the power 1 plus 3 and M13. What is your M11, M12 and M13? M11 is your minor, and minor of M11 you can find out by solving the determinant. So 1 plus 1 A11, this is here 3. So minus 1 to the power 1 plus 2 means cube, minus 1 to the power cube is minus 1, so here place of minus you can write plus, you can write minus 2, and what is A, B21, B23, C31, C33. How we write? The M12 means, here you see M12 means for this element, so in this element you have to omit this column and this row, so the remaining element is this, okay. So for the third one you have to omit this row and this column. This is because you are expanding along the first row. And the next one is minus 1 to the power 1 plus 3, 4. This is positive. So we get plus A13. What is your M13? So it will be B21, B22, C31, C32. Okay. So after solving this, you will get the value of your determinant. Okay. So when I give you the examples or solved sums, then it becomes much clear to you. Okay. Next, we will move to the topic, the properties of determinants. Properties of determinants. There are various properties. Using those properties, it becomes easier for you to solve the determinants sum. Okay. So the very first property is the value of determinant remains unchanged the value of determinant remains unchanged if its rows and columns are interchanged. If its rows and columns are interchanged. Okay. Means, suppose you have a determinant A, that is A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. So first row, second row, third row, first column, second column, third column. Okay. Now, if you interchange in place of means your column become rows and rows become column. 1, A2, A3, B1, B2, B3, C1, C2, C3. Then the value of this one and this one are equal. Here you have interchanged the, we have learned in matrix interchange of rows and columns. So in place of rows you write columns, and in place of columns if you write rows, still then the value of determinant remain same. This is the very first property. I will give you the sums related to each and every property. Now the second property. What is the second property? The second property is, if any two rows of a determinant, any two rows or columns of a determinant are interchanged, then the sign of the determinant changes. If any two rows মানে আমি কি কৈছো যে যদি দুটা ৰো বা দুটা কলমক তুমি ইন্টারচেঞ্জ কৰা, মানে এটা ৰোৰ ঠাইত তুমি বেলেগটো লিখি দিয়া আৰু হেতুক তাৰ জায়গাত লিখি দিয়া, তেতিয়া কি হ'ব? For determinant are interchanged, then sign of determinant changes. Suppose we take the determinant, this one. Suppose one thing I forgot to tell you that determinant can be, this is the symbol for determinant, triangle. Okay, so instead of writing this one, you can just write this determinant. And one most important, in matrices you have a square bracket. Okay, but in determinant it is not bracket. If you by mistake in matrices you just put this two sign, then your whole sums will be incorrect. Whether you do the each and every calculations correctly, but if you put modulus sign or determinant sign in place of matrices or second bracket, then everything will be incorrect. Okay, so be careful. B1, B2, B3, C1, C2, C3. Suppose the value of this is x, then if you interchange the, so this is delta 1, you interchange any two rows or columns. Suppose here I have written B1, B2, B3, and here I have written E1, E2, 3, and it is, then its value will be minus x. Numerical value is same, but the sign get changed. Here it is positive x, here it is negative x. Okay, so the next properties we will discuss in our next video.